Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video I'm going to attempt to take a Raspberry Pi computer and control a stepper motor with it. The stepper motor I'll be using is a Nema 23, which in the stepper motor world, that's mid to large size stepper motor. And if you come into this video today as a regular viewer, you're probably expecting to see machining content. There won't be any machining in today's video. However, if what I'm attempting to do today works out, I have a very practical use for it here in my little hobby machine shop. That'll be covered in subsequent videos. Now, if you're coming here because you did a search on Raspberry Pis and stepper motors, then I'll give you a quick little background on myself. I'm a retired programmer, and as a retirement gift to myself, I set up a little hobby machine shop, and I do videos sometimes weekly, sometimes bi-weekly, of machining content. But I like to throw in a little bit of programming along. I like to continue to do a little bit of programming as necessity, or what I deem necessity, comes up. And in today's video, we're going to combine a little bit of programming with a little bit of electronic layout, if you will. What I want to do is take this Raspberry Pi. Now, this is a Raspberry Pi 3B Plus. It's plenty big for the purpose of what I'm doing here. Raspberry Pis come with a series of pins down one side. Some of these pins are grounds, some of them are plus 3.3 volts, some of them are plus 5 volts, and the majority of them are what's called GPIO pins, general purpose input output. So what we'll do is write a program that will send a signal to one of these GPIO pins that'll go through the stepper motor driver. I'm using this is from Stepper Online. It's a DM542T. We'll go into more detail on that in just a minute. But I use one of these pins to control the direction of the stepper motor. This is the Nema 23 stepper motor. One of the GPIO pins to control the direction, clockwise or counterclockwise, and another of the GPIO pins to control the pulses. Now, unlike a standard DC motor or AC motor for that fact, but this is more in the family of DC. With a DC motor, you apply the positive and negative, and as long as you apply power, it rotates, turns. When you reverse the polarity, the plus and minus, it turns in the other direction. Now, that's good in a lot of cases, but it's not good where you need precise movement of the motor shaft. What a stepper motor does is you apply a pulse, and that pulse is enough to step this one time. A Nema 23 requires 200 steps to make one revolution. So that's what we'll do with the Pi. We'll send 200 pulses for each revolution we desire on this. Okay, what I want to do right quick is give you a rundown of the pinouts on the Raspberry Pi. Here's the Raspberry Pi. Again, remember I showed you two rows of pins down this side. Now, this is a blow up of them. As you can see, some of them is 3.3 volts, some of them 5 volts, some of them are ground. And then in this case, there are 27 GPIO. There's 40 pins in all, 1 through 40. They number 1 1, 2, 3, 4, 5, 6, and so forth through 40. The GPIO pins are numbered 1 through 27. I'm going to be using the 2 down here at this edge. GPIO 21, this one right here, we're going to use it to control the number of pulses we send to the controller. GPIO 20 we're going to use to set the direction on the controller. Now the controller itself, the DM542T, has several hookups here that we're going to be dealing with. These top 2 are the pulse or the step. And you remember I said we're going to go to pin 21 with that. Pin 21 will be to this pulse positive. The pulse negative will be hooked to one of the grounds on the Raspberry Pi, one of the pins that we said was a ground. The direction plus will be pin 20 from GPIO pin 20 from the Raspberry Pi, and the direction minus will be the again from one of the negative ports pins on the Raspberry Pi. Now let's come down here to the bottom. We got a B minus and a B plus, a minus and an A plus. Those are the pairs from the stepper motor. This is the, okay, I had to refresh my memory a little bit. On this card though, it tells us that the black and green again are one set of windings, and they are the A windings. So the black is the plus, it'll go to the A plus, the green will go to the A minus, and then the other pair, the red will go to the B plus, and the blue will go to the B minus. Now the only other piece of equipment in this whole equation is this generic 48 volt DC power supply. This controller will operate from 18 volts to 50 volts. So we're going to use a 48 volt power supply. Now if you attempt to do this, let me give you one little piece of information that you won't find, or I didn't find in any other videos on YouTube, and didn't find it anywhere in the little guide that came with this stepper driver. On the top of it, there's a little switch, and it says 5 volt or 24 volt. If you're using a Raspberry Pi, you want this in the 5 volt position, because that's what's going to come out of that pin is 5 volts. When I originally set this up, the switch came from the factory on 24 volt, and it wouldn't do a thing. Alright, let's take a quick look at the overall wiring diagram. Okay, here's the overall wiring diagram, and hopefully you can see this, but I'm going to attempt to put a copy of this wiring diagram in the corner of your screen so that you can see it as I'm doing the actual wiring. But quickly, what we're going to do here, we're going to take pin 19, pin 34. Remember I said these pins are numbered 1 through 20, 21 through 40. The GPIO pins, those that are used for input-output, have a different numbering sequence, and we'll get to that in the programming. But we're going to come from pin 34 here, which is a ground, black wire, and run to the pulse negative and the direction negative on our stepper driver. Then we're going to come from GPIO 20, which is pin 38, with a yellow wire, and come down to the direction positive. We'll bring an orange wire from GPIO 21, which is pin 40, orange wire to the pulse plus. Now that has the Raspberry Pi connected to the stepper now, to the stepper driver. Then over here from our stepper motor, we're going to run the black to the A+. Remember, that's what it told us on the little card that came with it here. Black goes to the A+. We're going to run the green wire to the A-. The red wire will go to the B+, and the blue wire will go to the B-. Now our power supply down here, this is the 48 volt power supply. It of course will simply plug into the wall, but from it we got plus voltage, which will go to the second pin, volt DC plus. The negative side will go to the negative pin on the power supply. So I'm going to get set up now to actually do this wiring. Okay, I've gone ahead and finished putting the Raspberry Pi in its case. So we'll set that to the side for just a second. Now on the stepper driver, our wiring diagram said that we want to go the pulse positive, which is the top one here. We're going to use the orange wire. So let's insert that in. Alright, and we said the yellow one would be the direction positive. Then we said we'd have a negative on the pulse negative, or a black wire on the pulse negative and the direction negative. So I just made up a simple little Y cable here. Pulse negative is the second pin from the top. And then the direction negative is the fourth pin from the top. If you use a different stepper controller, stepper driver, you may have different pin locations. Alright, now let's hook these to the Raspberry Pi. We said the orange one should go to GPio 21, which is on the very bottom on this outside row. We said the yellow would go to GPio 20, which is the next to the last pin on this outside row. And those are GPI numbers were 20 and 21. Pin numbers were 40 on the end, 38, second one. Now the ground is going to go to pin 34, which is the fourth one from the bottom on this outside row. So we should have the Raspberry Pi hooked up now. Our stepper motor, the top wire, our little diagram that came with it, said that the black wire was the A+. So we'll hook that in the A+ position. The next one on here is the A-, which is the green wire. The B+ is the red wire. And the B- is the blue wire. Now I need to pause for just a second here and explain on this. There's this set of dip switches on the side. I told you about this switch up here needing to be in 5-volt position if it was running off a Raspberry Pi. Well, these dip switches down here are dependent on what stepper motor you're using. Switches 1, 2, and 3 is for 4.5 amps. You'll have to look on your stepper motor or what come with your stepper motor, find out what the amperage is on it, and find the closest one on here that's higher than or equal to the amperage of your stepper motor. This stepper motor I think was rated at 4.2 amps. This says a 4.5 amp to turn switch 1, 2, and 3 off. So that's what I've done. 1, 2, and 3 up position is off. Switch 4 is whether you want half current or full current. I honestly don't know the benefit plus or minus of why you would want the half current. I've got it on full current. Now the other 4 switches are how many pulses per revolution. This says, the little card that came with this said it's a step angle of 1.8 degrees. If you divide 360 by 1.8, you come up with 200 steps per revolution. So for 200 steps per revolution, switch 5, 6, 7, and 8 need to be on. So those are on, are in the down position, which is on. So now we have the stepper motor and the Raspberry Pi hooked together. Now, as you can see, let me be sure that's, yeah, I want to be sure that was in there good. As you can see, I can turn the motor now. Once we apply power to this, one of the things about a stepper motor is that it has holding position. So it will hold it and takes quite a bit of torque on a motor this size to move that with power on. And you don't want to move it with power on. All right, let's get our power supply close by over here. Ground is a black, and then again this is a 48-volt power supply. The positive is the second one on here, the plus volt DC. Power supply is unplugged right now, by the way. All right, let's be sure nothing sparks. All right, I plugged that in. Now, I can't turn this motor. This motor is tight now. So there we have the wiring. We're going to turn to the computer in just a minute and spend the rest of the time on this video going through about a 35-line program that I wrote to step this motor back and forth. All right, what you're seeing on the screen now is the screen of the Raspberry Pi, the desktop of the Raspberry Pi. I'm sure by this point some of you are wondering why I didn't use an Arduino instead of a Raspberry Pi. My reasoning behind that is that the practical application that I have for this setup is going to require user interface. If I understand a Arduino correctly, you basically write a script for it, upload it to the Arduino, and it runs. And it is what it is. With the Raspberry Pi, I'll be using the Python programming language and run the script. And again, in my application, I will need to interact with that. Every time I run it, I'll need to pass different parameters to that. Now we're going to look at a much simpler program today where it's not going to take any parameters, it's just going to run. Up in the upper right hand corner of your screen you can see the end of the stepper motor, and I've got a line drawn across that. But what I want to do is go through this 35 line Python program. I say 35 lines, but let's see, there's 1, 2, 3, 4, 5 blank lines, and then there's 2 that are just display something on the screen lines. So there's 7, 35 minus 7, only 28 lines to get this running. But I want to go through it one line at a time and hopefully help you understand how this program works and how you control the stepper motor, or how you send information to the driver for the stepper motor. First thing we're going to do is import from the time library. We're going to import the function called sleep. That is just going to allow us to pause the program along each time. We're also going to import a library, RPi.GPIO, and we're going to give that a name of lowercase gpio. This is the library written for Python that allows us access to those GPIO pins on the Raspberry Pi. Now, first thing we're going to do is, or next thing we're going to do is define a few variables here. The direction pin, if you recall when I wired it, was pin 20. GPIO pin 20 to control the direction. The pulse pin, or the step pin, we're going to use 21. And I'm just giving those a name. I could use the variable, or I could use 20 and 21 throughout the program. But I'm giving them a name to make it a little easier to follow later in the code. Clockwise direction is basically a boolean, true or false. We're going to set it as 0 to begin with. Counterclock direction, we're going to set to 1. Now that 0 or 1 is what we're going to send to this direction pin, but you'll see that a little bit later. GPIO, again, is this library we imported. We're going to set the mode to BCM. BCM says we're going to use the numbering sequence of the GPIO. If we set this to board, we will be using the numbers 1 through 40. But I like using the GPIO pins. As far as the ground is concerned, it doesn't matter what pin we use for ground or what pin number we use for ground, just as long as it's one of the grounds on those 2 rows of pins. Now we're going to set up 2 of those GPIO pins, gpio.setup. The direction pin, we're going to tell it that it's an out pin, meaning we're going to be sending a signal out pin 20. The inverse of that, if it was a pin that we were looking for a signal back from, such as a limit switch, would be a GPIO in pin. That's beyond the scope of this discussion today. We may get to that in a later video. But we're going to set the direction pin as an output pin, and also the pulse pin as an output pin. Now we're going to set GPio output, the direction pin that we just defined up here, to the clockwise direction. All that's going to do is initialize it, so the first time we send the pulse to it, it's going to go in the clockwise direction. Throughout these loops down here below, we're going to be reversing that from clockwise to counterclockwise. Next, Python has what's called a try except. Try means we're going to try this code right here, but if it fails, we're going to do this exception down here. And the only reason this shouldn't execute is that a keyboard interrupt, the Control-C, has occurred. So to stop this program, we'll just hit Control-C on the keyboard, and that'll trigger a keyboard interrupt, and we'll get down here to this in just a second. But then we're going to run a while loop, another Python function called while true. Now true is always true, and that would be the same as saying while 1 equals 1. So this is going to continue right here. And if you're not familiar with Python, Python indentation is what controls the start and ending of loops. So while true, we indent over, it's going to run everything that's indented over, loop around, until it sees a keyboard interrupt. Next thing we're going to do is simply print on the screen that we're turning clockwise. Remember, we set we initialize that pin to the clockwise direction. We're going to sleep a half a second now. That's just to give the Raspberry Pi plenty of time to settle down. That doesn't need to be near that long, but I want that between changing directions between clockwise and counterclockwise. I want just a little sleep period here, so it's going to be half a second. Now remember, we initialize that output pin as clockwise direction. Well, why are we setting it here again? Well, once we get through this while loop one time, it's going to get set to counterclockwise, so the next time we come here, we need to set it back to clockwise. Now we're going to say for x in the range of 200. X is just a variable name. It could be anything. It could be for ABC in range 200. Now this is actually, X is going to count from 0 to 199, which is 200 loops around this for loop right here. Remember, we said this Nema 23 requires 200 pulses for one revolution. So we're going to send 200 pulses to the driver, and the driver in turn is going to massage that and send it out to the stepper motor. So let's do a GPio output, the pulse pin, that's 21 up here, set it high. Let's basically apply a little bit of voltage to that pin. Now we're going to sleep for 1/1000th of a second. Remember, we're not applying steady current to that pin. We're applying pulses. So we sleep for 1/1000th of a second, and then we set that pin back low. We pause for 0.5 of a second, 5/10,000ths of a second. We sleep, and then we go right back in this for loop right here until we reach 200, actually 199. So what that's going to do is going to continue this loop right here for 200 pulses. After that 200 has been reached, it'll drop out of this for loop and come down to the next section of our while loop. Then we're going to print on the screen counterclockwise. Sleep that 0.5 second to give time between the device going in one direction and changing directions. This is somewhat of an arbitrary value right here. Now we're going to change the direction pin. Remember, that's pin 20 up here. We're going to output to the direction pin the value of CCW, counterclockwise direction, which is 1. Up here we sent out a 0 to that pin. Here we're sending out a 1 to that pin. And we're going to basically do the same thing here 200 times. We'll set the pulse high, pulse pin high. We'll leave it high for 1/1000th of a second. Then we'll set it back to low right here. We'll delay 5/10,000ths of a second and continue this for loop. Now the speed of how fast it rotates, how fast it goes through this 200 iteration here is this second sleep in here. How long we're going to sleep before we go back around. So this while loop is going to continue forever. Remember we said true is always true. So that's going to keep going, keep going, keep going, round and round this while loop. And while it's in this loop, it's going to go round and round 200 times here, round and round 200 times here, 200 pulses. Then it's at the bottom of the while loop, so it comes back around again. That's just the nature of Python. If a Control-C has been typed on the keyboard, it will instantly find this. No matter where it is in this code, it will instantly find it and fall out of the try loop down to the except loop and recognize a keyboard interrupt. And what we want to do there is run this function called gpio.cleanup. What that does is clean up any orphan commands that might have got sent to the pins. When I say orphaned, we've sent to this direction pin either a 0 or a 1. Now, when the program ends, we need to clean that up because it starts out without a value. Same thing on the GPI, the pulse pin, whether it's high or low, we need to reset that. So any orphan value that's left on these pins will get cleaned up here and the program will end. This again is just a small indication of the user interaction with that. Now in the upper right hand corner of your screen, you'll see the stepper motor. I'm going to run this code right quick. I need to plug the power supply in. Now when I click the run button up here, you're going to see a little terminal window, black screen pop up here. And the only thing that's going to appear on it is direction clockwise or direction counterclockwise. And that will continue until we end. So let's see if everything runs. You remember in our code, we're doing 200 pulses, so that's doing 1 revolution. That's how fast it's going through these 200 here. You see the indication on the screen. All right, let's stop that now, Control-C. Now let's do something a little bit different. Let's go, instead of 200, let's go 600. That will be 3 revolutions in each direction. Let's run it. You can see it's doing 3 revolutions in each direction. Now let's make the counterclockwise go twice as fast as the clockwise does. So instead of 0.0005, we'll go 0.00025. Now when it starts in reverse now, counterclockwise, you'll see it going twice as fast as it goes in the clockwise direction. All right, let's change this back to 1 revolution. And I'll change that back to 5. But let's say we didn't want it stepping that fast. We only we want it to step much slower than that. And by setting this down to 1/10 of what it was, you're going to see the actual steps in the motor now. See how much slower that's going? Let me slow it down even more. Now you can see it's stepping, and it's going to take considerably longer to do 200 steps. All right, when it finishes that, you can see it went back at our normal speed. That in itself is, again, one of the reasons that I wanted to use a Raspberry Pi versus an Arduino for this particular project, because I will need to be able to dynamically, I'm going to be moving a table back and forth with pulleys on the stepper motor. And based on the work that I'm doing on that table, I'll need to determine, it might be 1 revolution, but more than likely it'll be closer to 10, 15 revolutions. And I'll need to be able to specify that when I execute this program. I'm going to put this code in the description below. Now, the description uses a proportional font, which means everything is not going to line up like it does here on the screen. But if you're familiar with Python, just reformat it, putting 1 tab over for the file true loop, 2 tabs over inside the for loops. Okay, so there you have a simple layman's explanation and demonstration of hooking up a 48-volt power supply, a digital stepper driver, stepper motor, and controlling it with a Raspberry Pi 3B Plus computer. And then the code to actually run on the Raspberry Pi. Hope you've got a little enjoyment out of this, and possibly if we're looking to do the same thing, controlling a stepper motor with a Raspberry Pi. I hope you found this information useful. Take care, stay tuned to the channel, because like I say, I've got a practical use for this. All I'm doing now is waiting on the pulleys and belt to get here. Take care, and I'll see you on the next video.